to our webinar. What is the SafeTpack? SafeTpack is the safety solution for the AURIX TC3xx microcontroller family. SafeTpack is designed to cover the most common AURIX safety manual requirements for a lot of applications in automotive and industry. The AURIX controller is a complex device with numerous internal safety mechanisms. The developer must ensure that all the safety mechanisms function and trigger the correct reaction in the event of an error. The safety mechanisms of the AURIX are documented in the safety manual. In total, the AURIX documentation consists of many thousand pages. We have developed SafeTpack to implement these basic functions quickly and safely. SafeTpack is based on more than 10 years of AURIX functional safety know-how. Our message for you: concentrate on your application know-how. Reinventing the wheel costs time and money. With SafeTpack, we cover a lot of AURIX know-how for you. SafeTpack is ProSil ready. ProSil is a trademark for Infineon for their functional safety products, and provides a rapid way to achieve your ASIL goals. SafeTpack saves time, money, and your nerves. And that's new. We not only support 26262, SafeTpack will be certified for 61508, SIL 2 and SIL 3 in the mid of this year. What does SafeTpack offer? SafeTpack provides interface to execute and evaluate your startup test. SafeTpack supports the necessary internal safety mechanisms, external safety mechanisms, and safety mechanism configurations for a lot of applications. SafeTpack provides cyclic tests that ensure the correct operation of the AURIX TC3xx CPU and internal buses through a mixture of hardware and software modules. SafeTpack manages the watchdog system and an optimized and optional combined watchdog and power controller, for instance, the TLF35584 or 85, or the NXP PMIC FS45 or 65XX. Definition of safety mechanism. The safety concept of the AURIX is mainly based on many safety mechanisms to cover as much as possible faults, which can occur during the product lifecycle. Many of these safety mechanisms are implemented in the hardware of the micro itself. But there are a lot of more of them required, which have to be implemented by the integrator. These are so-called external safety mechanisms. And here the safety library comes into the play. As per the X3xx safety manual, there are more than 120 assumptions of use in terms of external safety mechanisms and safety mechanisms configurations. How to implement these safety mechanisms? Some developer means no software is required because the second generation of AURIX has a lot of tests now realized in the hardware, like the logical built-in self-test or the power built-in self-test. But it's only the one part of the consideration. In the safety manual, there's still a long list of assumptions of use, which you have to take care about it in your use case to fulfill the requirement of your safety standard and level. Here's just a short list what you have to do. You have to implement, configure, and trigger to evaluate your startup tests. You have to implement, configure, execute, and evaluate your runtime tests, like SFR registers and die temperature sensor. You have to implement, configure, and handle functional window watchdog like the external TLF and the AURIX internal safety watchdog. You have to follow the development process given by a safety standard, and much more. And that's what the SafeTpack is designed for. And how to integrate SafeTpack? see part 2 of our webinar. SafeTpack has 2 main packages. The right side of this picture is SafeTpack Basic, which supports the startup and ESM support and configures the SMU of the TC3xx over the MCAL SMU driver. On the left side, we have SafeTpack Watchdog, which supports the internal watchdog, the external watchdog like the TLF or the NXP watchdogs. There's a special add-on for the TLF 35584 and 84 startup test driver, and we have an add-on as a program flow monitor. But these are details where Anastasia will go more in detail. SafeTpack is designed to use with or without AUTOSAR. In AUTOSAR environment, SafeTpack is a complex device driver, but SafeTpack does not use any functions of an RTOS or AUTOSAR, so it's totally independent from the real-time operating system. But SafeTpack is compatible with the Infineon MCAL drivers in terms of compiler versions and Tracer Studio. In non-AUTOSAR environments, for instance, in ISC 61508 applications, SafeTpack can still be used independently. For Hitex PXROS HR environments, for instance, SafeTpack implementations are available. SafeTpack is fully configurable with Tracer Studio. The Tracer Studio as a configuration tool is included in the deliverables of SafeTpack. SafeTpack comes complete in source code with a demo workspace, with Electrobrick Tracer Studio and the desired plugins, example Tracer's configuration, and demo code. Documents for the SafeTpack is the user manual and the safety manual, release notes, the configuration verification manual, a demo description, SafeTpack validation report, and safety case report. With these documents, especially with the validation report and the safety case report, you have all documents you need for final certification of your application. SafeTpack is still in development, so we plan to have at least 1 maintenance release per year. So we now support the NXP PMix for FS 45XX or 65XX. And with the next maintenance release, the maintenance release 3 in Q2 of this year, we will support the 35585 PMIC of Infineon, and we will support all compiler versions for MCAL 2.20. On the other hand, the certification for SafeTpack according to SIL 2 or SIL 3 is available in Q3 of this year. You're missing some ESMs or SMCs? Okay, just tell us. Maybe we will integrate it in one of the next maintenance releases. And in our roadmap, TC4xx support, so the successor of TC3xx, is on our roadmap. Our services around SafeTpack and functional safety. We highly recommend for the first integration of SafeTpack in a given application, our web-based training for SafeTpack integrators. This is the first-hand information with valuable hints on safe and reliable integration. And it's highly recommended if you start your first project. This webinar is held by an experienced developer of SafeTpack, and you can ask your special questions during the webinar. Project-related consulting is another possibility we offer for you. So for AURIX-related questions and functional safety and security. On the other hand, we offer SafeTpack integration services into your application as a full service, SafeTpack customization, and last but not least, hardware and software development in the context of AURIX and functional safety, and embedded testing and verification. Now I have to say thank you for your attention till now, and I hand over to Anastasia.
Thank you very much. In next 30 minutes, we'll dive in more technical details, how SafeTpack works and how you can integrate your software application in our SafeTpack environment. So let us see. Now we will speak about your safety goals in your software project. Also, we will look in more details how SafeTpack works in SafeTpack test phases, startup and runtime tests. And of course, we will learn about possibilities to integrate your software application with SafeTpack. So before we will start, I would like to ask you a question. Would you like to make your software application safe and reliable to the functional safety standards? For instance, for the automotive standard ISO 26262, for instance, you would like to get ISIL B, ISIL C, or ISIL D level, or as Michael mentioned, to be certified with one norm, it's 61508, and to make your software relevant to the C levels. If so, of course, you have already your safety goals in your software, but what you need to do is to transfer these safety goals to technical safety measures. It can be done via internal and external safety measures, as Michael already mentioned. So for instance, you have your software in AURIX environment, and in this environment, you will need to make voltage monitoring, watchdog services like time window and signature watchdog, perform error monitoring, and set safe state control. And all of these tasks can be done by SafeTpack at one product. So how does SafeTpack actually works? Michael mentioned that SafeTpack consists of two packages. Actually, that's true. There is a main package and 3 add-ons. But buying SafeTpack, in any case, you will get source code for each package and, of course, Trezos tool with configured Trezos plugin. At the same time, you will get a demo workspace. It's our software which shows the setup process for SafeTpack and also Trezos example configuration. And then the main package will be SafeTpack basic package, which includes test handler, test library, and of course, external and internal safety measures library. And then 3 add-ons, SafeTpack watchdog with internal watchdog, external TLF watchdog, and NXP services. Then SafeTpack watchdog test or SafeTpack TLF. It performs startup tests to the TLF safety manual. And of course, SafeTpack program flow monitoring. This package monitors the program execution flow for safety critical applications. Our package system makes easier for you to customize and implement individual functions, and depending on your precise requirements or your specific software definition, different SafeTpack packages can be selected. So SafeTpack actually it's a library of tests, and there are several test phases like a startup test and runtime test. What is the difference between them? Startup test runs only once. The result of this test is the safety measurement unit initialization. The test signatures after the end will be sent to the test manager, but not yet consolidated. And of course, all test results will be provided to the caller of the function. Actually, it's test handler in SafeTpack. The runtime test run cyclically during the diagnostic time interval. During the runtime test execution, the safety measurement unit is locked, and test results will be fully provided to the test manager as a caller of the function. At the same time, all test results as test signatures will be consolidated, and you will get results either test is passed or failed. So how the process of testing starts? Actually, it starts with SafeTpack basic. Then we will need to activate SafeTpack watchdog. Then runtime starts in again in SafeTpack basic. We will perform the watchdog services together with SafeTpack watchdog, SafeTpack TLF, and at the end with SafeTpack program flow monitoring in order to consolidate test signatures and get the results, either test is passed or failed. So now let us see more technical details, and I will explain the SafeTpack architecture. So the main SafeTpack package is SafeTpack Basic. It consists of test handler, which is responsible for the test execution. Also consists of test library. Actually, it's a collection of tests required to be establish the integrity of AURIX device. Also, every SM and ESM, internal and external safety measures, are listed in test library. Below you can see several tests as LBIST, M2, and other ones. So I will explain you how this test can be performed in few next slides. Then we are going in upper layer, which consists of your software application, and your application will be connected with Test Manager and Watchdog Manager. So the Test Manager is the caller of SafeTpack drivers, and it's responsible for integration with AutoSAR. Also, it's responsible for generation of consolidated test signature, and also it transfers all results to SafeTpack Watchdog during the runtime test. Then Watchdog Manager. Actually, it's responsible for the servicing Safe Watchdog during the diagnostic time interval and consolidates the test signatures from Test Manager. Then one of our SafeTpack add-ons, SafeTpack Watchdog. It consists of SafeTpack. It consists of Watchdog interface in SafeTpack, external TLF Watchdog, and internal safety Watchdog. As a result, it works also with QSPI driver. So in SafeTpack, we support multiple watchdogs, and watchdog interface abstracts the functionality of underlying watchdogs depending on the function. For instance, internal safety watchdog, it abstracts its functionality in logical and temporal monitoring, while the external TLF watchdog abstracts the TLF services, and its driver supports for window watchdog and functional watchdog of TLF. So also we have here add-ons as TLF test driver. Actually, it's part of watchdog services and of course program flow monitoring add-on. We will look in more details in few slides to get idea how the runtime test process works and how we can consolidate the test signatures. So now you got idea how SafeTpack works in static mode. So you have already learned the SafeTpack architecture. Now let us move to more dynamical things. Especially we'll look at dynamic process of microcontroller unit and in the startup process. We will start with AURIX hardware, which is in gray color here, and then continue to the process how to integrate your application in the startup phase in SafeTpack Basic. So we are starting with AURIX from Infineon. We are switching power on, then making reset, initializing firmware, initializing a microcontroller unit, and the first hardware function is LBIST function. Actually, this function will be transferred to your application in the upper layer. I hope that you still remember the SafeTpack architecture. So actually, here in upper layer, you have the same structure. Then this function will come to the test manager and later to the SafeTpack Basic. Now let us look how the process of startup tests looks like in SafeTpack Basic. So now we are in SafeTpack Basic, which consists of test handler, the test executor, So test handler sends this command to the test library, and in test library, we are performing the startup test and getting the LBIST function results, which will be transferred from test library to test handler, and then back to test manager. On next slide, I will show you the sequence of startup test. So let's see. We are starting with application, so each test must be initialized. Important to know, this example is valid only for the startup test in SafeTpack basic module. How to activate Watchdog and how to run runtime test, I will show you a little bit later. So we are initializing our test, first of all, from application to test manager in upper layer. Then when initialization is done, we are starting our function or our test, which is transferred from test manager to test handler. Then in test handler, it will be sent to test library, and the LBIST logic built-in self-test, the first test, will be actually performed with the result. After the test execution, we will start the next test, which is MonBIST, secondary monitor built-in self-test, and actually the same procedure. When this test is done, we are starting with the next test, which is firmware check. After them, safety management unit, a live alarm test, and of course, non-destructive memory built-in self-test. After the test completion, we will send the command which safety management unit can be initialized, so it's activated. And in SafeTpack Basic, the startup test is completed. Now we will look how to activate watchdogs. We are at the same build, but now let us look in SafeTpack Watchdog. Actually, it consists of watchdog interface and then two modules, external TLF watchdog and internal safety watchdog. Both of them performing logical supervision, temporal supervision, and at the same time, at external watchdog, we are performing AURIX test, which is analog built-in self-test, and diagnostic test, which consists of or including check of window watchdog, functional watchdog, and of course error pin monitoring. When all tests are performed, then watchdog is activated. So at this phase, we are ready with startup test, and the next phase will be a runtime test. So the runtime test is more complex process because runtime tests are cyclical. In runtime test, we are performing two tests at SafeTpack Basic via a test handler. It's die temperature test and special function register test. At the same time, we are performing the internal and external watchdog services. So we already saw then that in SafeTpack Watchdog, we have two watchdogs, internal safety and external TLF. So in this case, we are performing simultaneously two concepts in our watchdog. It's external question answer watchdog, which is used for logical and temporal supervision. And in this case, external watchdog provides a random value for internal program flow monitoring. The result of this process will be signature, which later will be consolidated. At the same time, in second concept is internal safety watchdog together with external time window watchdog. In this case, the internal safety watchdog performs the logical and temporal supervision of all tests. And after that, watchdog provides a random number which is transformed to SID and also sent to the internal program flow monitoring. So it means that we are becoming two test signatures. One is from watchdog services, another is from program flow monitoring, and both of these signatures are consolidated. So you can see it on this slide. You can see that from one core, we will get one test signature, from second sort, and next course we will get another test signatures, and all of them will be consolidated and assigned to each function. Yeah, this process is quite complex. So several signatures can be consolidated in and transferred them into statuses. If test is passed, then we will get OK status. If tests, if there are tests which are failed, we'll get the error message, and some of these messages you can see in this table. So here you can see the error codes which are relevant to the SafeTpack basic drivers, and of course with a description how it works. So now you know the main processes in SafeTpack and the general workflow of tests. Now let us switch to the question how integrate your specific customer software application with our product SafeTpack. As I already mentioned, the SafeTpack includes source code for each package and of course Trezor tool with pre-installed plugin for it. In our demo workspace, you will get software to set up SafeTpack and also to see Trezor's example configuration. So today, in the integration process, I will focus your attention on our demo workspace, and I will use it as an example. Actually, what is integration? It's the process to build in and configure SafeTpack in your application. So there are some pre-requirements how to do it. First of all, you will need the Trezor tool, actually, which is already pre-installed in SafeTpack. You will need bfaces to build a framework for your demo. You will need compiler tool like Hitex or Tasking, for instance. You will need evaluation board for AURIX and of course debugger tool for AURIX in order to view the test results. So first of all, what you need to do is to run the SafeTpack installer. I'm pretty sure that you know this process from Windows interface. And after the SafeTpack installation, you will get such folder structure, actually, which shows you the whole static integration process. So here you can see the whole SafeTpack architecture with test library, test handler, watchdog services, also integration interface and MK resources. Then you will need to configure your SafeTpack with Trezors. Actually, it's as a plugin is already pre-installed in SafeTpack. You will need to select your Trezors and configure to SafeTpack modules. And then you will need to create your own workspace with bfaces for SafeTpack. And of course, configure the parameters for test phases as startup and then runtime. So you know the process of startup and runtime already, and then you will need to configure a special function register for your runtime phase. After that, you can start to build your application within SafeTpack environment. With Trezor, you have already generated configuration files, and you can then compile and link them into your application. And of course, after the startup and runtime test run, you can make your test signature check and of course evaluate your test execution and look at signatures, either test is passed or it's failed. For instance, here on this build, you can see the startup test and its signature results and runtime with their signature results. And actually, after the test signature evaluation, the integration is done. So all processes are completed and your application is successfully running in SafeTpack environment. So I would like to say a few words about SafeTpack maintenance. As Michael already mentioned, Hitex provides continuous development of SafeTpack product. It means that we are performing mid-distance twice per year the SafeTpack maintenance with a new SafeTpack version. And actually, every new SafeTpack version includes additional internal and external safety measures. It means if you are missing some safety measures for your project, for your software, please contact us to get the newest SafeTpack version for your application. Here you can see my contact details. So if you have some specific questions about SafeTpack integration, please write me an email. And many thanks for your attention and your interest in SafeTpack.